for the Apollo program that took us to the moon. And then after the Apollo program ended in the early 70s, it was transformed to be able to handle the space shuttle. If you look up there, you can see where that big giant crane is. That's a 175-ton crane, and it translates down the length of the transfer aisle. And up in the upper parts of the high bays, there are 350-ton cranes. And they translate between the high bays back and forth across the building this way. If you look way up inside there, you can see a big hole in the girder work, and that's where High Bay's 2 opening is. And you can't see it much on this side, but the opening for High Bay 1's on this side. And then farther down, the openings for the other 2 are 16 floors up. So when we decided to use this building for processing the space shuttle, it became a different kind of an animal, because Apollo had cylindrical rocket parts, and of course the shuttle has wings, and they stick out to the sides pretty far, and the wings wouldn't fit through the hole in the girder work up there. So the crane operators, when we lifted the vehicle vertically to made it to the external tank, they had to rotate the wings 45 degrees, fit it through the slot in the high bay, and rotate it back 45 degrees. So I like to brag a little bit that we got the coolest crane operators in the world here. Anyway, pictures on the wall back there kind of tell the whole story. You can see the center picture. It shows you the lifting sling that we use to lift the orbiter off of the transporter. The orbiter will be brought in here from the orbiter processing facility right across the street on a transporter and brought right into the center of the transfer aisle. We had 2 cranes waiting. The 175-ton crane in the front, and 350 in the back, and the 350-ton crane in the front. And both cranes would lift simultaneously. Would pull the orbiter off the transporter, drive the transporter out from underneath it, and then raise the forward crane and lower the aft crane, and then remove the aft crane altogether. So you're hanging from a single hook in the middle of the transfer aisle. And it's pretty amazing too, because I don't know how much you guys know about steel rope and cranes and stuff, but the rope on the cranes actually stretches under the load, and it's a 350-ton crane, and it's only lifting 250,000 pounds, but it still moves. It sits there and does this. It's just amazing. And so once we get it all stable, we lift it 16 floors in the air, take it through the transom, and then lower it down between the platforms, the tank, and the orbiter, and not hit anything. And there's about this much clearance on each wingtip. So it was a pretty delicate operation. And I had the great pleasure of doing it, I don't know, 30 or 40 times, I guess, running the whole operation. So it was always a dicey deal.
Now you lifted with both cranes because you had to do the handoff, you said?
Well, you lift both cranes off because you're in the horizontal when you start. So there's no other way to do it.
That's right.
Yeah. So you raise it off the transporter, get the transporter out from underneath it, and then raise the forward crane, lower the aft crane.
Gotcha.
Yep. And then the picture on the left over there is how we handled it's hard to see with this thing in the way, but that's how we would process the external tank. It would be brought by barge from the machine assembly facility in Louisiana and offloaded in our turn basin right near the building here, and brought in on a transporter and lifted with 2 cranes again, do the rotation from horizontal to vertical, and we put it up into one of the high bays in high bay 2 or 4 and do the final processing on the external tank to get it ready to fly. In the right hand picture, you can see the entire assembly put together. And once we have assembled the solid rocket boosters, the external tank, and the orbiter on the platform, on the mobile launch platform, the crawler transporter would come in, pick the entire thing up off the ground, and roll it to the pad and set it down at pedestals at the pad. Before we roll out of the VAB, though, since we just finished putting everything together and making all the connections, we do a full-up integrated set of tests to make sure everything is connected properly and that everybody's talking to everybody else. To give you a simple example, the nozzles on the boosters gimbal. You know what gimbaling is? Gimbaling means the nozzle can steer. So both boosters have nozzles with hydraulic systems that can steer that nozzle via the Guidance Navigation and Control System, GNC. And so the computers that are in the cockpit of the space shuttle are connected to the Guidance Navigation and Control System, and they send signals through the umbilical in the belly of the orbiter that goes through to the external tank, and then from the external tank through wiring harnesses to the solid rocket boosters. So if the Guidance Navigation and Control System, after we lift off, says, I'm not going in the right direction and I need to correct, it sends a signal through the hydraulic system to gimbal that nozzle in the opposite direction of where we want to go. And so all those connections have to be made perfect before we roll out of here, because once we get out of here, we get to the pad, we don't have access. Because we have platforms so we can gain access to everything in here, but once we get to the pad, we lose a lot of that access. So it's really important that everything is done properly so you don't have to inadvertently roll back to fix something. So it's all on a time scale too. You're worrying about getting to launch date. So anybody got questions?
I got
Yeah?
How thick is the flooring?
How thick is the flooring?
Yeah.
That's a really good question, and I do not know. But I would guess it's on the order of 6 feet or so. Maybe more.
6 feet of concrete and rebar.
Well, let's walk down a little farther and see if we can get any. Unfortunately, they won't let us go any farther than here today.
Unfortunate? Just unfortunate to be here. Ooh. Sorry, I see wall and I see names.
This thing on the wall over here is where everybody came and signed the wall that worked on the space shuttle program, and my name's up there somewhere. And I don't remember where it is, and I can't find it. So this vehicle assembly building has stood the test of time. It's weathered hurricanes. It's now being transformed to handle the new flight hardware for the Space Launch System. I don't know how much you guys know about that, but this is going to be the biggest rocket in the history of the planet. And I wish I were going to be around to launch it, but unfortunately I'm retired now, so that's not going to happen. But the space shuttle, when we lifted off, had a thrust of about 7.5 million pounds. And its liftoff weight was about 6.4 pounds. 6.4 million pounds, and our thrust vector was about 7.5 million pounds. And so this new rocket's going to be about 11.5 million pounds. And it'll lift a payload of about 180,000 pounds to low Earth orbit in one shot. The space shuttle, we could lift a rag, depending on the angle of trajectory, we could lift about 50,000 pounds to low Earth orbit in one shot. So the shuttle was a real workhorse. And of course, you probably know it brought all the parts and pieces for the International Space Station up. But this new rocket is going to be able to lift 3 times what the shuttle could lift in one shot. And that's really important because if we're ever going to go to Mars, which you guys will live through, because you're a lot younger than I am, you need to be able to bring big parts and pieces up, because we're eventually going to build what I would term a transfer vehicle that will be built in low Earth orbit and will be used to transport crew and cargo to and from Earth orbit and Mars orbit. We'll never land on either planet. We'll use different vehicles to go down to the surface and back up again. But this transfer vehicle has to be built to enable us to translate between here and Mars and Mars orbit back and forth many, many times over. So that's going to happen in you guys' career lifetime. So you should look forward to maybe working on some of that. So who all's in what discipline here? Do you have mechanical engineers? Yeah, electrical? Yeah, computer? Yeah,
Computer,
cool. Chemical? Ah!
Yes.
Who did I miss?
Environmental?
Right here. Probably the only.
So do you guys have any other questions?
I have a look.
Yes.
How tall is the building?
Well, actually, we're right on the edge here between the low bay and the high bay. And the high bay ceiling, the roof is 525 feet.
525 feet.
I read that Wikipedia said that building is the largest building in the world. One single line.
I don't know if that's true or not.
One single what?
It's the largest building, the building that has the largest single volume. They open.
Well, that's Wikipedia. I don't know.
Yeah, well, yeah.
Well, it is one of the largest buildings by volume in the world. I know that. I don't know that it was. I don't know all this. I'm pretty sure there are other buildings that are bigger, actually. Maybe not in height.
Yeah, it might not be that.
I don't know.
I was attracted.
All right.
I can tell you a quick one here. Yeah, actually, what time are what's your schedule?
Kim did this together.
Where are you going next?
We're going over to LC Security Guard.
Well, I'm taking you there.
Okay, so it says right to that's at 110. Depart. We're supposed to depart at 1.
Okay.
So you got 10 minutes.
We're good.
We're
Good.
good.
Well, actually, I have to be somewhere after
okay.
2, so
Yeah, okay.
anyway.
Okay.
We were, this was probably 1993 or 4, and that was a very busy time here because in the mid-90s we were flying 6, 7, 8 flights a year. And so the space center was literally humming with activity. There were 16,000 people working here, and we worked 3 shifts around the clock, 24/7, 365. I mean, we didn't take days off. You didn't take weekends. You didn't take holidays. You didn't go to your anniversary. You know, it was just work. It was crazy. But we rolled Atlantis in here one night, and got started on the lifting procedure to mate it to its external tank. And we were just lifting the shuttle off of its transporter with both cranes and getting ready to start rotating from horizontal to vertical. And as the nose of the vehicle started to go up, we heard a loud clang noise. And I called all stop right there, and nobody moved. And we went up with a high ranger, one of those things that was blocking the photographs. We went up in that thing, and we took the temporary door off the aft compartment and showed a flashlight in there and looked. And what did we find but a big giant yellow beam, which was part of the ground support equipment platform set that we put in the vehicle in the aft compartment to gain access inside there, so you could put people in there to do work. We used to have a platform set that goes in the horizontal, and then before we roll out of the OPF to come over here to go vertical, we'd remove all those platforms. And those platforms are painted bright yellow so you can't miss them. And yet somebody missed one. And we left it in there, and we rolled over here, we started to rotate, and that beam fell when we started to lift it. And when I saw that yellow beam in there, I was like, oh shit, we are in for it now. No, actually we spent like 4 days inspecting the aft compartment to see if anything bad had happened, and luckily we got through with no damage. But it was a big lesson.
The guy who left it in there.
Well, this is where the story is leading to, is that we now had perfected, after that, we perfected a method for maintaining control of everything that went in and out of the aft compartment, or the mid-body, or the forward compartment. So we use barcodes, and then for stuff that you couldn't really barcode, like paintbrush or tools, we now have a tool control standard practice instruction, and every toolbox, the drawers are shadow boxed with slots cut in so that the tools fit in certain locations. So all you do is open the door, and you can tell at a glance that all the tools are in there. And so you inventory the tools at the beginning of the shift, you inventory the tools at the end of the shift, and it's the manager's responsibility to ensure that all the tools are accounted for. And if somebody's missing, I'll stop until you find it. I'll stop until you find it.
Did that ever happen?
Yeah, we would lose tools and then find them again, and you'd find them in the most unbelievable places. But the whole idea though was that you absolutely can't leave stuff loose inside a spacecraft that's going to fly at 17,000 miles an hour.
Right.
Just don't do that. It can cause catastrophic failure, and that's what we're all about: avoiding catastrophic failure. We can live with some risk, but what we do is really risky. And so the whole game is about minimizing the risk. And so the smarter you get about doing dumb stuff, like doing inspections and closeout photographs, and accounting for tools and parts and equipment, and making sure it's where it's supposed to be and not where it isn't. Those are the simple things that we as engineers learn all this fluid dynamics and all this computational capability and all this other stuff. And it really comes down to really stupid, dumb stuff. Like not losing a tool inside something.
Or getting your units of measurement.
Or getting your units of measurement mixed up. Yeah, do we do metric or SAE or All right, let's head out. We're going to go to the LCC.
Appreciate it.
Oh,
Yeah.
oh, question.
He didn't hear you.
I know you didn't hear me. Oh,
Yeah, you could. A long time ago. Not anymore. Yeah, we built a false ceiling up there, and that is conditioned space up there, so you can't have that.
Yeah, so I thought that was
That big giant tank
long
is
time
used
ago
to
when they didn't have
load
the
test the
climate
crane.
control they have around.
Oh, okay. In other words, we can fill the tank with water to a certain weight, and then use that weight to test the cranes with.
oh, cool. Quick question. I heard a rumor like a long time ago that the VAB building has its own weather.
Yeah, you just asked that. It used to, until we built a false ceiling below the real ceiling,
Right.
and after we did that and air conditioned the space, it doesn't do that anymore.
Yeah, because like I heard rumors that like it could be sunny outside, but like storming rain inside the VAB.
Nah, it never was that bad. We would get some moisture, but it wouldn't be like raining or nothing.
Yeah.
Yeah.
This is for these parts.
These were part of the Apollo program. These were where certain parts of the rocket would be processed prior to being lifted into place. Yeah, we haven't used those since Apollo. So are you guys in the middle of college, or are you getting close to graduation? Or
Yes. And,
your second year?